So now we talk about discriminant of a polynomial. So let f of x be a monic polynomial of degree n, and this alpha 1 to alpha n be the roots of f of x. So discriminant of f of x, you write it as alpha j minus alpha I squared. So let us see an example and compute the discriminant. Say alpha is 2 to the 1/3 and the minimal polynomial would be x cubed minus 2 equals to 0. So the other root corresponding to this is omega, which is minus 1 plus square root of 3 times I, which is complex I square root of minus 1 divided by 2. Now this is the third root of unity. So the conjugates of alpha are, so these alpha 1 to alpha n, they are roots of f of x and they are conjugate to each other. So the conjugates would be alpha 1 is 2 1/3, alpha 2 is omega 2 1/3, alpha 3 is omega square 2 1/3. So you compute alpha 1 minus alpha 2, which will be 1 minus omega 2 1/3, alpha 2 minus alpha 3, omega 1 minus omega 2 1/3, and yeah, so just alpha 3 minus alpha 1 like this. So you have to know that this j has to be greater than I, but you have a square here though, so it doesn't really matter. So discriminant of alpha you can write like this, and then you just multiply it out. So you have omega times omega square will give you omega cube. You square it, you get omega 6, but this is just the third root of unity, so omega cube is 1, so this becomes 1. And then you have this, you multiply 2 1/3, 2 1/3, 2 1/3, you multiply these three factors, you get 2, you get square it, you get 2 square, and you just get 1 minus omega to the 6 here. So to compute this, let us just see 1 minus omega square. So you expand it, you get 1 plus omega square minus 2 omega. But recall that 1 plus omega square is equal to 0. So 1 plus omega square is equal to minus omega. So this is equal to minus omega. So you get minus 3 omega here. Now raise it to the power of 3. So you get minus 3 cube and omega cube. So omega cube is anyway 1. So you're left with minus 3 to the power of 3. And you have to raise it to the power of 3 because we are worried about this 1 minus omega to the 6. So we have been able to find the discriminant of this alpha. So you remember this discriminant because we have to come back and compute it again via a different method. So now we will give a discriminant of a polynomial through a different method. So a different form of discriminant is given by this proposition. So consider an irreducible monic polynomial, this f of x, with coefficients in this field k, and let alpha be the root of f in some splitting field. So then discriminant of f of x is given as minus 1 to the power of n times n minus 1 by 2, then norm of k alpha over k. We are adjoining alpha to the base field k, and then you take derivative of f with respect to alpha. So to prove this result, we will use this this fact. So norm of a polynomial g of alpha is just product over g of sigma I of alpha. So we have already seen that norm of alpha is just product of the sigma I alpha, but if you take norm of g of alpha, then this g will carry over here. So just think of it in terms of if g is an ID map, then we already know this result. So now we are saying g could be any polynomial. Now discriminant of f of x is just right here. So this we are copying here. So this f of x will factorize in some splitting field, and it factorizes like this. And so this alpha n to alpha n are the roots. So these roots are coming here because we are saying it will factorize in some splitting field. And now you can use product rule to compute its derivative. So the only non-zero terms would be where I is not equal to j. So you just use product rule to compute, write it as a sum of terms, and all the terms will go to 0 where alpha I will be equal to alpha I. So alpha I minus alpha I would be 0. So only this term would remain where I is not equal to j. So now we can multiply this over all I to get this product I equals to 1 to nf. So you have this. So just we are adding a product here this side. So this product also carries over to this side. So now from here we want to go here because only then we can show the discriminant. So here we have I less than j. So from here we want to go I less than j. So you want this right hand side to write it like this, I less than j, and then square it because you're taking product twice, so you will have a square. So you have this pair I comma j, so you will collect all pairs of alpha I alpha j. So with these pairs you can just get two things, you get alpha j minus alpha I, or you get alpha I minus alpha j. If you multiply these two, because you're taking product here and then product here again, so this you take negative out, so you will get alpha j minus alpha I with a negative sign. So you can multiply these to get a square and get a negative sign, because this is of opposite sign like this. So in how many ways can you choose this pair ij out of these n? Because we have alpha 1 to alpha n, so the roots are n roots. So number of ways to choose is n choose 2, which is just n times n minus 1 by 2. So this minus 1 has to be raised to this power for the number of ways you choose it. So therefore this square, so this becomes this will become a square if you raise it to the power this minus 1 n minus 1 2, and this product, so this product you can write like this now. So that is it. So we have shown this, and now this equality just follows from here. So instead of g we are writing f prime, so you get norm of f prime of alpha. So yeah, so we had to make a square here, and we were able to make a square here by just choosing I and j appropriately, and n choose 2 was the term, and this negative we had to raise to the power of this so as to get this equality. So now let us do an example. So let alpha be 2 to the 1/3, and minimal polynomial is x cubed minus 2, which is equal to 0. So the degree of this 2 1/3 over q is 3, and for a in q, so if we just take a in q, this degree is 3. This is actually the dimension of the space. You have this as a cube, norm would be a cube, because we know now our corresponding matrix for norm just looks like this, because we are taking a from the base space, this space here. So this is a cube, trace would be 3a. So discriminant of f of x, we are saying we are using this formula here. So minus 1 to the power of n to the n minus 1 by 2, norm of k alpha over k f prime of alpha. So what is f prime of this? F prime of this is 3x square, and f prime of alpha would be 3 alpha square. So let us compute this norm first. So norm of 3 alpha square. So norm is multiplicative, so you have multiplicative here. So this becomes norm of 3 times norm of alpha square. But this 3 is rational number, it is coming from here. So you will have 3 cube here. So you have 3 cube, and norm of alpha is 2, precisely because the norm is the constant term of the minimal polynomial. So that is the constant term here. So norm of alpha is 2. Since it is multiplicative, the square comes out, so you have 2 square. So you get 3 cube times 2 square. So now we have to worry about this first part. Now since n is 3, you plug in 3, you get this as 3. So minus 1 to the power of 3 is minus 1. So this becomes minus 1. So discriminant becomes minus 3 cube times 2 square. And this is precisely what we computed with the previous method.